Hello everyone, this is Team 73. In this project, we use three algorithms, which are heuristic, Q-learning, and min-max.
Due to the time constraints and the complexity of the Azul game, we at first use a specific and suitable heuristic algorithm which can make each step as efficient as possible to find a locally optimal solution. We have developed a heuristic algorithm based on the differences between our scores and the opponent's scores. This algorithm is shown for missing results and lays the foundation for future algorithms.
Due to the limitations of heuristic algorithms, it is challenging for them to handle overly complex situations. Therefore, we have implemented Q-learning, as this algorithm can continuously update the strategy for selecting actions based on feedback from the environment. We use three features and information related to our own chessboard as reference for the bit vector. We successfully developed an algorithm that can continuously refine its strategy. During local testing, we found that the performance of the Q-learning algorithm gradually becomes stronger through reinforcement.
The last algorithm we use is min-max algorithm, which is also the best performance one. Considering the game feature of Azul, our goal is not to achieve a high score, but rather to win over the opponent. So in our heuristic algorithm, we made a simple guess about the opponent's scores. However, due to the computational time limitation and the simplicity of heuristic algorithm, we couldn't accurately predict the opponent's scores, and sometimes our guesses even backfired. Therefore, we thought of min-max algorithm. The min-max algorithm is suitable for turn-based board game where players moves and alternative, so that this algorithm can find the best next move that maximize their own score or minimize their opponent's scores. This made the min-max algorithm ideal for two-player board games like Azul. The min-max algorithm can select the next move based on the current game state and the current player. It can be applied in each player's turn to find the best move strategy within the limited search pace. It is easier to win a game by predicting your opponent's performance while improving your own performance than a general heuristic algorithm.
During our testing, the biggest challenge becomes how to make relatively optimal decisions with the limited time. We observed that the conventional min-max algorithm would have a timeout at depth 2, resulting in a loss of the game. And even when applying alpha-beta branching, a timeout would occur with depth 3.
To address this, an extra experiment has been employed, which is depth-Stacy function. Depth-Stacy function aims to strike a balance between accuracy and computational efficiency. When the number of possible actions is small, the depth-Stacy will be slow, allowing for deeper predictions and more accurate evaluations. Conversely, when there are numerous possible actions, the depth-Stacy is accelerated to prevent a significant impact on the algorithm's runtime. This is a test we run locally, where Agent 0 is a regular heuristic algorithm, and Agent 1 is our optimized min-max algorithm. By combining the depth-Stacy function and alpha-beta pruning, the min-max algorithm for Azul becomes more efficient, providing a balance between accurate evaluation and runtime. You can see that the performance for both is very closely in the first each step of each round. However, it is clearly that, in the final stage of each round, min-max algorithm can clearly make more brilliant choices that force the opponent to lose points.
The quality of the evaluation function plays a significant role in determining how effective the min-max algorithm will be. It can be difficult to design an accurate and complete assessment function for complex games like Azul. At the moment, the evaluation function simplifies based on the score of game states, including bonus and penalties. It is possible to construct a more comprehensive assessment function that takes into account the more important factors. Thanks for listening.